Hi everyone, this is the video working out Unit 10-11 review. So if you have any questions, make sure you watch this video and you ask for help. So looking at number 1, calculate the exact value of sine of 7 pi over 12 by using the difference identity. So again, we're using the difference identity, and it's going to be for sine. So if we look at our reference page, the difference identity is the second one for sine, where we are subtracting a and b. So I'm going to go ahead and write that out. So we have sine of a minus b equal to sine of a times cosine of b minus cosine of a times sine of b. What I need to do is I need to split up 7 pi over 12 into two fractions that I know, or two radians that I know. So if I split it up, I don't want to use 1 pi, or actually no, I need to be able to subtract those two values. So two values that subtract, well, I know 10 minus 3 is 7. So if I split up 7 pi over 12 into sine of 10 pi over 12 minus 3 pi over 12, let's see if those are two values that we know. So if I simplify 10 pi over 12, that they're both divisible by 2, so I get 5 pi over 6. And then if I simplify 3 pi over 12, those are both divisible by 3, so I get pi over 4. And both of those angles I should know. So now all I'm going to do is plug them in to the formula. So I get sine of 5 pi over 6 times cosine of pi over 4 minus cosine of 5 pi over 6 times sine of pi over 4. So now all we're going to do is we're going to evaluate each of these values. So here we go. Sine of 5 pi over 6, that would be your ring finger down. It's in the second quadrant, so that would be a 1/2 for sine, and it's positive. Cosine of pi over 4 is rad 2 over 2. Minus cosine of 5 pi over 6. 5 pi over 6 for cosine is a negative rad 3 over 2. And sine of pi over 4 is rad 2 over 2. So now I'm going to multiply them out. 1 times rad 2 is rad 2. 2 times 2 is 4. Here I have a negative rad 3 times times rad 2, which is negative rad 6, but that minus sign turns it into a plus sign, so I get rad 6 over 4. And then all I need to do is write it as one big fraction, rad 2 plus rad 6 all over 4. I look at my answer choices, and it's in a different order, but C still is the correct answer right here. Now, if you're not sure, how can we use our calculator to help us? Well, if we're going to use our calculator, we are going to type this into the calculator, making sure that we type it in radian mode. So I'm going to switch over my calculator. I'm going to go to my settings. I'm going to make sure that I have it in radian mode. And again, you need to know how to do this, because when it comes to the test, I will not be helping you. So we have sine of 7 pi over 12, and we get this decimal. So what we're going to do is we're going to type in our answer choices to see if we get the same decimal. So we have, for answer choice A, rad 2 minus rad 6 all over 4. We see that that is not the same decimal. Then I see I have a negative rad 6 minus a rad 2 all over 4. I see that is not the same decimal. It is close, but it's negative. So then I go to the one we said that was correct, rad 6 plus rad 2 all over 4. And notice how that decimal matches the one that we wanted. So that's how you can check your work with the calculator. Okay, moving on to question number 2. Solve the equation below for 0 to 360. So this tells us that our answers are going to be in degrees. So what we do first is we're going to subtract 3 from both sides. And that gives me sine x is equal to -1. So I need to identify the value where sine is -1. That would be at 270 degrees. If you weren't sure what to do, I'm going to show you how you could use your calculator. So we're going to go back to the calculator. And what we're going to do is we're going to plug in those different x values into the equation to see which one would give us 2. So this one, because our answers are in degrees, we need to make sure that we switch back to degrees right here. And I believe this might be the only question we have in degrees. So if I type in sine of 90 plus 3, again, our goal is to get 2. In this case, we get 4. If I do sine of 180 plus 3, we get 3. Again, our goal is to get 2. I type in sine of 270 plus 3, and I get 2, which is what I want, so everything works out. Moving on to question number 3, we're going to simplify the expression below. When we are simplifying like this, our goal is to get everything in terms of sine and cosine. So that's going to be my first step. Secant is 1 over sine theta times tangent, which is sine theta over cosine theta. So I see here that sine theta is on top, sine theta is on bottom. I cancel out. So what that leaves me with is 1 over cosine theta. And if you look at your identities, 1 over cosine theta is secant theta. What I've noticed is that we often forget if it's in the numerator or the denominator, so please be careful with that. Now, if you went blank or if you just want to check your work, what we can do is we can graph our answer choices, and see which one is going to give us the exact same graph. So if we go over to our calculator, this time we're going to go to the graph screen, and we're going to type in first, we need to make sure that it's back in radian mode. So switch it back. And then we're going to type in secant. So I have secant. Instead of theta, I'm just going to use x times tangent x. I have that. I'm going to go down. I see the graph. I want it to cover that blue graph. So if I graph sine x, I see that it didn't cover anything. It's down there. Okay, if I graph cosine x, again, it didn't cover the blue graph. Oops, wrong button. If I graph cosecant x, it got close, but it's not quite there. And then if I graph secant x, I see that that green graph covered the blue graph that I wanted, so that's how I can see my answer using a calculator. Moving on to the next one. What of the following is a solution to the equation where 0 to 2 pi is our domain restriction? So to do this by hand, because it's already in factored form, all we're going to do is set each factor equal to 0. Then I'm going to solve each equation individually. So I'm going to start by subtracting 1 from both sides. That leaves me with a 2 cosine x equals -1. And then I divide both sides by 2, and I get cosine x equals a -1/2. So I'm trying to find the values where cosine would equal a -1/2. So there should be two x values where cosine equals a -1/2. The first one would be 2 pi over 3. The second one would be 4 pi over 3. Then I do the exact same thing, and I'm going to solve my second equation. So this time I'm going to subtract rad 3 from both sides. And those cancel out. I forgot to mark those out over there. It leaves me with a 2 sine x equals a negative rad 3. Then I'm going to divide both sides by 2. And that gives me sine x is equal to a negative rad 3 over 2. So again, I'm trying to find what angle would give me a negative rad 3 over 2. That would be 4 pi over 3 and 5 pi over 3. So if I look at my answer choices, I notice that pi over 6 is not one of them, pi over 3 is not one of them, 7 pi over 6 is not one of them, so that leaves me with answer choice D, 4 pi over 3. And both of my answers did contain that, so that is one of them that is a solution. Okay, they don't have to be overlapping to be a solution. It just happened in this case. So if we wanted to use our calculator, all we need to do is we need to go back to the calculator screen. We're going to plug in the different x values to make sure that it equals 0. So I go back to my calculator screen and make sure that our angle is in radians. And we're just going to type it in. So we have 2 cosine. I'm going to type in pi over 6 first. Then I have plus 1. Make sure the plus 1 is not in the parentheses with the pi over 6. Then I have 2 sine x, and so I'm going to type in pi over 6 again. Plus rad 3. Make sure the rad 3 is not in the parentheses with the pi over 6. I press enter. Notice it does not give me 0. So if I go up and I just press enter, then I don't have to retype the equation, and I can just edit the angle that I typed in. So the next angle is pi over 3. So I'm going to just change the 6 to a 3. In both of my angles, you got to make sure you do both of them. I press enter. Again, I do not get 0. So if I just hit the up arrow 2 times, press enter, I don't have to retype in the whole equation, saves us some time. So 7 pi over 6. Again, I don't get 0. Up arrow 2 times, press enter. Now I'm going to change it to 4 pi over 3. And that right there, even though it looks funky, what that means is you're going to move that decimal place 26 places to the left. And if I move that 26 places to the left, I have negative 0.00025 times, which is 0. So anytime you see that, that means 0, as long as it's a negative number after the E. So that would be our answer right there. Moving on to the next one, we want to simplify the expression below. So first thing I'm going to do is start by making it all in terms of sine and cosine. So this is already in cosine. I don't have to worry about it. but secant is 1 over cosine minus cosine squared. I don't have to worry about that. I notice that if I put the cosine over 1, I have a cosine on top, a cosine on bottom. So that just leaves me with a 1 minus cosine squared. So we're looking to see what it simplifies to. If I go to my identities page and I look at this Pythagorean identity, if I were to subtract cosine from both sides, it would leave me with a sine squared, and that's currently what I have, 1 minus cosine squared. So my answer is just sine squared x, and I see that that is answer choice C. If you weren't sure or you just wanted to double check your answers, we could graph these. So we switch over to our graph. We're going to discard our changes and go to a new graph screen. And again, make sure that we're in radian mode. So radian mode, and I'm going to type in the original problem that we have. So it was cosine x times secant x minus cosine squared. So to type in cosine squared, you do parentheses, cosine x, double close the parentheses, and then you square it. So the squared should be on the outside. And when we graph it, let's see, it looks like this. So we want to make sure that it is covering that blue graph. So when I type in my next one, negative cosine squared, so parentheses, cosine x, close, close, squared, I see that the red did not cover it. I go to my next equation, 2 parentheses, cosine x, close, close, squared. That did not cover it. I go to the next one, so it's sine x, or sine squared x, so parentheses, sine x, close, close, squared. And I see that the purple graph did cover my blue graph, and that's how I know it's my answer. Going to the next one, we're going to solve the equation below for 0 to 2 pi. So I have this right here. I'm going to start by adding 2 to both sides. When I add 2 to both sides, I get 2 cosine theta equals negative 3 plus 2 is a negative 1. These 2's cancel out. Then I'm going to divide both sides by 2. And this leaves me with cosine theta is equal to a negative 1/2. Now my goal is to solve for for theta. And there are 2 angles where cosine is equal to a negative 1/2. That is 2 pi over 3 and 4 pi over 3. That is the second and the third quadrant. So if I look at my answer choices, the only one that has both of those is answer choice D. So if we wanted to check our answers, we would plug them in. You start with one angle at a time. If the first angle doesn't work, then overall it's not going to work. So we go over here, we go back to the calculator screen. Again, we have to make sure that our calculator is in radian mode. And then I'm going to type in my first one with pi over 6. So I have 2 cosine with pi over 6 for theta minus 2. And our goal is to have it equal 3. That doesn't work. I go up 2 times. So automatically A is out because that angle did not work. So then I have pi over 3. I plug it in. I get negative 1. I want a negative 3. That does not work. So that answer choice B is out. I go up 2 times, press enter. I'm going to change my angle to 7 pi over 6. I press enter. I do not get negative 3 by itself. I don't want any decimals attached to it. So then I go up 2 times. I'm going to change it to 2 pi over 3. I press enter, I get exactly negative 3. I'm going to double check my second answer. Should always double check. And we get 4 pi over 3, so I'm just going to change the 2 to the 4. And I get negative 3 for both of them, so therefore that's why answer choice D is your answer. Going on to number 7. So this one requires a little bit more work. If cosine theta is equal to 12 over 13, find the exact value of sine of 2 theta, where 0 to 2 pi is your domain restriction. So this right here is telling me that I'm only working within the first quadrant. What do we know about first quadrant angles? They are all positive. Okay, so since we know that they're all positive, that automatically eliminates answer choice A and answer choice C. So now you're down to a 50-50 chance. Because again, it cannot be negative in quadrant 1. What also is important is that we see sine of 2 theta, which tells us that this is the double angle formula. Or we need to use the double angle formula. So the double angle formula for sine is sine of 2 theta, let me not put parentheses, is equal to 2 times sine theta times cosine theta. So I know, I'm going to plug in what I know. I know that cosine theta is equal to 12 over 13. I need to find what sine theta is. To find what sine theta is, all we're going to do is use the Pythagorean theorem to help us out. So I have let me draw the right triangle over here. If I know this is theta right here, I know cosine is adjacent over the hypotenuse. So I know the adjacent side is 12. I know the hypotenuse is 13. If I want to find this side over here, I just use the Pythagorean theorem. So the Pythagorean theorem says that a squared plus b squared equals c squared. I know a is 12 squared. B, I don't know, that's our x squared. And c, we do know, which is 13 squared. So if I square 12, I get 144 plus x squared equals 13 squared, which is 169. If I subtract 144 from both sides, what that leaves me with is x squared equals 25. If I take the square root of both sides, I know that that is x equals plus or minus 5. But because we're dealing with distance, we only use the positive version. So I know that x is equal to 5. If I want sine is opposite over the hypotenuse. So that would be 5 over 13. And then all I have to do is multiply these two numbers together, or three numbers together. So when I'm multiplying, I'm going to treat 2 as a fraction as 2 over 1. I multiply the tops together. 2 times 5 times 12. Well, 2 times 5 is 10. 10 times 12 is 120. 1 times 13 is 13. 13 times 13 is 169. So my answer should be answer choice B. So now, how we're going to confirm this is with our calculator. So we need to make sure that we're in radian mode, which we should be. So let's double check. Yes. All we're going to do is if I want to find the angle and I'm giving a value, I'm going to use cosine inverse. And I'm going to type in the fraction they give me, which is 12 over 13. I press enter and I get a decimal. Then what I want is I'm going to evaluate it at that angle for sine of 2 theta. So I'm going to do sine of 2 times, I'm going to go up, highlight that answer, press enter. It inputs it so I don't have to type it back out. And I get 0.7100 and all those other decimals. Now all I need to do is double check all my answer choices to see which answer choice gives me this decimal. When I type in answer choice A, I have a negative 120 over 169. And notice how it didn't change it for me. So if I just go back up and after one of the numbers, I just put a decimal point, it will give me a decimal. That is the negative version of what I want. So if I just retype that and I take off the negative, which would be answer choice B, again, I have that decimal point after 120. I press enter, and that's the exact same decimal that I was wanting. So that's how I can confirm that B is my correct answer. Looking at the next one, which of the following is a solution to the equation below if 0 to 2 pi. So again, here is our domain restriction. I'm going to start by factoring out a greatest common factor. So the greatest common factor in this would be sine x, and it leaves me with tangent x plus 1. Now that I have it in factored form, I can set each factor equal to 0. And sine is 0 at 0, pi, and 2 pi. Then here, I need to subtract 1 from both sides. When I do that, I get tan x equals -1. Tangent x is equal to -1 at two values, the second quadrant and the fourth quadrant. And it's the ones with the denominator of 4. So that would be 3 pi over 4 and 7 pi over 4. So I'm looking to see if one of my 5 answers are there, and I see that it is answer choice B. Again, if I wanted to confirm my answer, I could type in all of my answer choices. Again, it's already in radian mode, but if you need to double check, it's there. So I'm going to start by plugging in my first answer choice for all of the x's. So I have sine of pi over 2 times tangent of pi over 2 plus sine of pi over 2. I press enter. It says it's undefined, which means it's not our answer. We move on to the next one. Again, if you go up 2 times, you press enter. All you have to do is change that angle to 7 pi over 4. So I changed all my angles and I get this right here. Again, that -13 after the E is telling me I'm moving that decimal place 13 spaces to the left, which is close to 0. If we plugged in any of the other answers, we would not get 0. So that is our answer right there. So you need to make sure that you understand that part, because I will not help you with that when it comes to the test. Next one. Mrs. Finnerty wanted to show her students she could simplify the expression. So we have her work. In which step did Mrs. Finnerty make her first mistake? What I think is easiest is if we just try to simplify it ourselves and check the work as we go. So if I'm starting with this, I notice that I have some like terms. I have a 4 cosine to the 4th power of x, and I have a -3 cosine to the 4th power of x. When I combine those like terms, 4 minus 3 is 1, so it just leaves me with cosine to the 4th of x. Next, I simplify the other like terms I see. I have 2 sine to the 4th of x minus 3 sine to the 4th of x. Well, 2 minus 3 is a -1, so I get a negative sine to the 4th of x. Then it's up to you to understand that this is a difference of squares. To the 4th power is a perfect square, so I can factor this as cosine squared x plus sine squared x times cosine squared x minus sine squared x. From here, it's up to you to understand that this right here is a Pythagorean identity. It does not matter that cosine came first, it's being added, so it's the same thing. So that turns into a 1, and it's still being multiplied by cosine squared x minus sine squared x. Now, let's go ahead and look over. So this first step that she did was correct. The second step where she factored it is also correct. And her turning it into a 1 is also correct. So far, so good. Now, notice that the sine squared is no longer there. So what it looks like she did is she replaced it with the Pythagorean identity that is solved for sine, which would be 1 minus cosine. So this leaves us with cosine squared x minus, and then this is where most people make the mistake. When I plug it in, I'm plugging it in right here, 1 minus cosine squared x. And I have to remember to distribute that negative sign. And so when I distribute that negative sign, I get cosine squared x minus 1. I distribute it to the negative cosine, and that turns into a positive cosine squared x. And so now I combine my like terms, and I have 2 cosine squared x's minus 1. And notice that is where the mistake was made. She did not distribute that negative properly. So this should have been in parentheses like that, so she could have distributed the negative. So the mistake was made in step number 4. Looking at the next one, we're going to solve 3 sine x equals 6 if it is between 0 and 2 pi. So we have 3 sine x equals 6. I am going to start by dividing both sides by 3. And that gives me sine x equals 2. Most people confuse that with 1/2. That is 2. And remember, I told you that sines answers are only between -1 and +1. This falls outside of that range restriction, so therefore this is no solution. So when you plug in your answers, it should not ever give you 6. So we go to our answers. Oh, let me switch over to the calculator. Again, we're in radian mode. So I'm just going to plug in the first answer choice. So we have sine, 3 times sine of pi over 6. I get 1.5. That doesn't work, so A is automatically out. I go up 2 times, press enter. I'm going to change this to 7 pi over 6. Again, I get a -1/2. I go up 2 times. Well, I already see that C has pi over 6, and we said pi over 6 did not work. So none of the answer choices worked that had numerical values, which leads me again to confirm that my answer is no solution. So if you're not in honors, that's done. You can stop watching the video. If you're in honors, we have 2 more questions. So which of the following expressions is equivalent to the given expression? I see that I have a cosine 2 theta and a sine 2 theta. Those are both double angles, so I'm going to replace those with a double angle. For cosine, there's 3 different options. I would pick the one that probably deals with a sine because the only reason, first off, there's a negative, but if we look at the denominator, it's going to be 2 sine x cosine x. And it's just going to make your life easier if you pick the sine identity, because if not, you'll have to do a little bit more work. But again, you can choose whichever identity you want to choose. So for the cosine one, I am going to pick the one that deals with sine, which is 1 minus 2 sine squared x. Oh, these should be thetas, not x's, so let me fix that. I need to make sure that I distribute the negatives, so that makes it a -1 plus a 2 sine squared x plus 1 all over a -2 sine theta cosine theta, and I did it again. That should be a theta. So what I notice here is that the 1 and the -1 cancel out. If I would have picked the cosine double angle identity with the 1 and the cosine squared, those ones would not have canceled out. If I picked the first one with the cosine squared minus the sine squared, I wouldn't have had anything cancel out. So that's why, again, I picked the one that I did. So now that I did that, what I'm going to do is I'm going to rewrite the top. Instead of saying sine squared theta, I'm going to say it's sine times sine. And then on bottom, I have a -2 times a sine theta times a cosine theta. This allows me to see that the 2's cancel out, but there's still a negative on bottom, and that one of the sines cancel out. And so it leaves me with a negative sine theta over cosine theta, and sine over cosine we know is a negative tangent theta. So that is my answer choice B. If we wanted to confirm this with a calculator, we're going to graph this one. So anytime we're simplifying, we graph. Anytime we're solving an equation, we're using the calculator. So I start with my fraction button. I have a negative cosine of 2x. I'm using x's instead of thetas, plus 1. Then I have a -2 sine x. And before I hit enter, it should be, oh, sorry, I put the 2 in the wrong spot, so let me fix that. Before I hit graph, I need to make sure that I switch over to radian mode. So it always needs to be in radian mode. Done. Oh, so I'm going to have to retype it in. That's okay, that's my fault. So cosine of 2x plus 1 over negative sine of 2x. I press enter. I want it to cover that graph right there. If I type in sine, if you know anything about the graphs, which you should, that's not the sine graph, so obviously it's not going to match. Then I type in a negative tangent x, and I see that that directly covers it up. Again, if you know anything about the shapes of the graph, it should have kind of given it away. So there's that. Boom. On this next one, we want to solve sine 2x minus 4 equals -3. So sine of 2x minus 4 equals -3. I know it's very tempting to try to use the double angle identity, but don't do that. You're not going to be able to solve it. So what we're going to do instead is we're going to solve it just like we do every other equation. I'm going to add 4 to both sides. And that gives me sine of 2x equals 1. So what we're going to do is we're going to identify when sine equals 1. And instead of just setting it equal to x, it's going to be equal to 2x. So that would be at pi over 2. Now, this next part is going to maybe be a little complicated. Because there's a 2 in front of that x, that means we're going to have to divide by 2, and there's actually an angle that falls outside of our domain, but when we divide it by 2, it puts it back in our domain. I know it's a little funky. So how I take care of that is I'm just going to put plus 2 pi in, and what that tells us is every rotation around, every 2 pi around, it's going to take us to that same location as pi over 2. So just trust the process. Now I solve for x, so that means I'm dividing each thing by 2. When I do that, I get x equals pi over 2 divided by 2 turns into pi over 4. And 2 pi n divided by 2 is just pi n. So notice how there's 2 answers. I know that my answer should have pi over 4. So if I look at it, it should be answer choice C. I want to show you how they got that 5 pi over 4. So to get it, they took pi over 4 and they added just 1 pi. But remember, to add fractions, they have to be like terms or common denominators. So I made this a 4 over 4, which is the same thing as 1. And that gives me 1 pi plus 4 pi, which is 5 pi. Denominator stays the same. So that is how they got that second answer right there. And that's why C is our answer. If you're checking this with the calculator, again, you're just plugging it in to see which one would give you -3. So I'm going to just go to my calculator. Again, make sure that you are in radian mode. I'll type in the first one so you can see. Sine of 2 times a fraction of pi over 2 minus 3. Oh, minus 4. It should equal -3. That one equals -4. It does not work. Enter or go up 2 times, press enter. If I switch it to 3 pi over 2, that's answer choice B. I get -4 again. That doesn't work. If one of the angles doesn't work, then neither of them will work. So I go to pi over 4. I see that I get -3. If I double check that second angle, which is 5 pi over 4, I get -3, and that's how I can confirm my answer. So that is the last question. You have a test tomorrow. Make sure you feel comfortable using the calculator for all of these because you will not get help during the test with your calculator. So make sure you know how to switch from degrees to radians, radians to degrees. And if you don't know how to do that, you need to make sure that you ask before the test. And again, you have a digital copy of this, so you can attempt this as many times as you want until you feel comfortable without using any kind of notes or support. So good luck. And again, if you have questions, make sure you ask in class.